All right, today's notes are again going to be on synthetic division and finding zeros of a polynomial. Goal: upon completion of these notes, students will be able to find the zeros of a polynomial. Also, the students will be able to write a polynomial with real coefficients in intercept form and standard form given the zeros of the polynomial. Now, this is just an extension of what we've done before, although here we're not starting you out with giving you a zero. And so, what we're going to do is find one in our calculator right away. So I don't have to give you one if you have your calculator, you can find one. All right, so I have my calculator here, and to save some time, that's actually the graph of this. I've gone ahead and typed it into y equals. All right, just type it in carefully, and then I hit zoom 6 to make sure we have a nice window. And our window here isn't the greatest. We know it's a cubic and we know the shape of that. And so I'm just going to adjust my window really quick, which I actually don't totally need to do. And I'm just going to guess that it really needs to go a lot higher than 10, so I'm just going to try 100. It's just a guess. I know that that part of the graph needs to be a little higher. We'll graph it, see what happens. Hey, it looks pretty good. All right, so we're used to the shape of things. Now, we found zeros in our calculator before. It looks like I have a nice one right there, but let's find out to make sure. It looks like x equals 1 is a 0. So let's try to find it, though. We'll have our calculator do the work. Second, calculate, or trace. And I want to find the 0, which is number 2. All right, so I'm going to use left bound, right bound. Now my cursor's right here. You can see at the bottom. And so left bound's already fine. I'm just going to hit enter. Right bound, I'm going to move my cursor to the right just so it comes to the other side of the x-axis, which is here, somewhere around here. And I'm going to hit enter. And then guess we don't do, we just hit enter. And yep, 1, 0 is an x-intercept. So that's really, for now, all I need my calculator for. So I know that 1, 0 is a solution. So I'm going to put this little 1 here like we've done before. Draw the little brackets. All right, and then notice we have a cubed, a squared, an x, and a constant, so I don't need any zeros for placeholders. So this part is synthetic division. The only difference is before in some problems we'd put like semicolon 1 and tell you that it's solution. Now you have to find one on your own. So we'll go back to the synthetic division process, and I'll put a 2 here, just the coefficients, 11 here, -7 here, and -6. This 2 drops down. 1 times 2 is 2. 11 plus 2 is 13. Hopefully we're really good at this by now. 1 times 13 is 13. -7 plus 13 is 6. 1 times 6 is 6, and when I add -6 and 6, I get 0. I absolutely knew that was going to happen. Why? Well, because we knew 1 was a solution. We absolutely knew that. All right, we found it in our calculator. Now, we're going to find all zeros, so I'm going to factor to do that and use zero product property. So remember, if 1 is a solution, then x minus 1, the opposite, is always a factor. And then we start out with a cubic. That means we go down by a power 1 to a quadratic. And we use these 3 numbers right in order for our new polynomial that goes right here. 2x squared plus 13x plus 6. And now we continue to factor if possible. All right, now the goal here is to solve. If you cannot factor this quadratic, you could use the quadratic formula. All right, so I have only one choice for the 2x and the x. And I should have said this before, I should look for a GCF, but there isn't one. All right, now if there's not a 1 in front of here, we're factoring like this. These two numbers have to multiply to give me some sort of middle x in this one as well. And these two add up to the middle. So I have two choices, 1 and 6. And 2 and 3 will both multiply to 6. And so I can tell right away 13 is a fairly big number. If I try the 2 and 3, I'm going to have a 6 here if I multiply by 2, or a 4. I don't think those are going to work. As a matter of fact, if I put the 6 here, and after you do many of these, you get experience. They become easier. 2 times that 6 will give me the 12x. And then if the 1 goes here with the plus, everything's a plus, 1 times x is 1x, and I have it. All right? So there's the factoring of that. Now, this problem said to find the zeros. If it said to factor, I'd be done. All right, so, and we also have to sketch a graph of it. So now, I'm going to say x minus 1 equals 0 and solve this using zero product property. X equals 1 is the solution, but we already knew that. This right here, we found ourselves. All right, but still listed down here as a solution. All right, then I'll take 2x plus 1. Set that equals 0. Just all three of my factors set equal to 0 and solve. Subtract 1 and then divide by 2. So x is, negative half. So there's another one. And then x plus 6 equals 0. So x equals negative 6 when I subtract 6. So all my answers are right here. All right, and in this case, they're all real solutions. Remember, we can have up to a max of 3 total solutions, real or imaginary. In this case, again, all are real. Now, we've done this before. We're going to sketch this. I have x equals 1 is an x-intercept. X equals negative half, so I'm going to have to ballpark that right here. And then x equals negative 6, so negative 1, 2, 3, 4, 5, 6. And here's the nice thing. I already know what this graph looks like, but even if I didn't use my calculator, you guys probably knew it looks something like that. So I'm just going to sketch it through there. It doesn't really matter how high or low you put these. Remember, our window is changed a little bit, but it's a positive x cubed, so we already knew the shape of it. But don't hesitate to use your calculator to help you out. So it goes something like this, like that, trying to curve it, and something like that. And that's good. All right. And make sure you hit your dots here. All right. So that problem is done. All right. This next problem. All right. Find all zeros of the polynomial function and sketch the graph of the given function. Really the same question as before. All right. Except for here, look, I have a fourth power. Now I want everyone to pause, put this in their calculator. Okay, pause. All right, now everyone should have this in their calculator. If you were struggling, maybe x to the fourth, just remember when you put x, you just type your x and then caret, which is this, to the fourth. Right? You should be able to put that in your calculator. All right, we're going to go ahead and hit zoom 6 and see what the graph looks like. All right, now this is interesting. It's a fourth power, and we've told you in class that sometimes the quartic, which is a fourth power, will look something like the squared, which is a quadratic, and this one does. All right, it looks like it crosses the x-axis here at 2. You just have to be sure that it doesn't cross twice there. All right, you can either zoom in, or we're going to go ahead and find the 0 there. So second trace, number 2 again. And usually your cursor is on your y-intercept. It's at 0, 16, which means I need to move it to the right and get the cursor down a bit. And you can see in your y values where your cursor is. So here it is. So left bound somewhere like that. I'll hit enter. Right bound, I'm going to move to the other side of where I think the x-intercept is. And it looks like it should be on the x-axis, and that's why it's not crossing the x-axis there. Then if I hit enter and then guess, enter, I get a x-intercept of 2, 0. All right, now because it's at y equals 0, this tells me a couple things. All right, we can go ahead and sketch the graph of this now. Might as well. And a couple things we'll find out about this. Let's go ahead and do synthetic division. So I have a 2 that goes here. We'll make this little box. And I've got a fourth cubed, a squared, an x, and a 16. Remember, if you're missing a term, you have to put a 0 for a placeholder. Here we're not. So I'm going to put the 1 there. Negative 4, 8, negative 16, and 16. All right, this 1 automatically drops down. Multiply 2 times 1 and get 2. Negative 4 plus 2 is negative 2. 2 times negative 2 is negative 4. 8 plus a negative 4 is 4. 2 times 4 is 8. Negative 16 plus 8 is negative 8. And 2 times negative 8 is negative 16. And be careful with all that math. I know again at the end, 16 plus a negative 16 should equal 0. If I don't get 0 there, somewhere in that process, I made an arithmetic error. All right, so now let's factor this further so we can solve it. F of x equals, if this is a plus 2, then I have the opposite, which is a minus 2 for a factor. Now, you could use a negative here, like it didn't happen in this problem, but if you had an x-intercept of a negative, you can use that. Negatives are okay. You can even use fractions, like a 0.5, you can use half. So in the previous problem, I actually just chose the 1 because it was a really nice number. If we slide up here really quick, I could have used any of these 3 numbers in the spot that we have circled up here. I just chose to use 1. I could have used negative half or negative 6. All right, so it just reminded me of that. All right, now this is a little different also, so we have to be careful. A little bit different problem that we've done before. We have a 4th power. What that means is we still only go down by a power of 1. So now I have a cubic, and these 4 numbers are going to be the coefficients of the cubic in descending order. So I go down 1 power from the 4th up here, and I have 1x cubed. I don't have to write the 1, but I did here. Minus 2x squared. Just go in order. Now, of course, you have to write the negative 2 plus 4x and then minus 8. Every once in a while down here, you'll get a 0. That doesn't mean you stop. You still keep going until you get a 0 at the very end. And then if you have a 0, of course, you skip that in that spot. So like if negative 2 is a 0, this would be gone. All right, anyway. So now we're going to continue on with this problem. And we're going to end up factoring this by grouping. There's 4 terms, and it looks like it will come out nice. So I've got an x squared that will come out of here as a GCF, which gives me an x minus 2. And I have a 4 that will come out of here, and that'll give me an x minus 2. So I factored the x squared out of these two, and the 4 out of these two, factored by grouping. All right. So that's going to leave me with an x squared plus 4 as one factor, and an x minus 2 as another factor. All right, now this says to solve. So I'm going to write down x minus 2 equals 0. Add the 2, x equals 2. We already knew that, but we're still going to write it down here. Now I'm going to skip over to this one. I have another x minus 2. I do not need to repeat that down here as a solution, but keep in mind there's really 2 2's, and so that's what's always going to happen when a x-intercept occurs as like a minimum or a maximum. So this is what's called a double root, and anytime you have a double root, you're going to have the solution taken into account twice. All right, so now I've got an x squared plus 4. So x squared plus 4 equals 0. Now here this doesn't factor because it's the sum of 2 squares, but because there's no x term, I can go ahead and solve by square rooting. So all those methods of solving are coming back. And not only that, I'm going to get imaginary numbers. So x equals plus or minus the square root of negative 4. All right, and that's going to be x equals plus or minus 2i. Now I should have expected that. If I have 2 solutions, now remember we have x equals 2 really taken into account twice. So there's 2 solutions of the 4. And since this doesn't cross anywhere else, then that gives me 2 imaginary. All right. Now you guys, we will talk about this last, whoops, went the wrong way. We will talk about number 3 in class. All right, we'll do that together. All right. Now I do want to show you one quick thing. I could have factored this and written it like this: x minus 2 squared, and then x squared plus 4, And this number right here tells you you have two of the same solution, the 2.